Have you ever wondered if there's a mirror version of everything we know? Today, we're not just exploring physics, we're diving into a cosmic mystery. We're going to talk about antimatter, the universe's elusive twin. So, what exactly is antimatter? Think of it like this: every particle we know has an opposite. Take the electron, for instance, it's negatively charged. Its antimatter counterpart is the positron, which has the same mass but a positive charge. It's like looking in a mirror, but instead of just reflecting your image, it flips the electrical charge. And it's not just electrons. Protons have antiprotons, neutrons have antineutrons, and so on. Every particle has a twin with opposite properties. It's like a cosmic dance where every step has a counterstep. Now, here's where things get really interesting. When a particle meets its antiparticle, they don't really bounce off of each other. They annihilate. Poof. They just disappear, and all their mass is converted into pure energy. Remember Einstein's E equals mc squared? This is it in action. A tiny bit of mass becomes a huge amount of energy. It's like the ultimate power source, if only we could control it. You might be surprised to learn that antimatter is already used in medicine. PET scans, or positron emission tomography, use radioactive isotopes to emit positrons. These positrons annihilate with the electrons in your body, producing gamma rays that doctors can detect. It's like using antimatter as a flashlight to see what's happening inside. This whole concept started with a theoretical prediction by Paul Dirac. He basically said, hey, there should be these opposite particles. Then Carl David Anderson found the positron in his experiments. It's a classical example of how theory and experiment go hand in hand in physics. Today, places like CERN are the forefront of antimatter research. They're creating and studying antihydrogen, which is an antiproton and a positron bound together. They're trying to understand if there are any subtle differences between matter and antimatter. It's kind of like comparing twins to see if they're truly identical. But here's the big question. If the Big Bang created equal amounts of matter and antimatter, where did all the antimatter go? We see galaxies, planets, and stars all made of matter. So, where's the antimatter universe? It's one of the biggest mysteries in cosmology. We're searching for clues, for any tiny differences that might explain this asymmetry. Imagine the possibilities. Antimatter could revolutionize space travel, providing incredibly efficient propulsion, or it could be the ultimate source of energy. But there are huge challenges. We need to figure out how to produce and store it safely. It's like trying to catch lightning in a bottle. We've explored antimatter, a universe of opposites, a cosmic puzzle. We know it exists, but where did it all go? That's the question that remains. This isn't just about particles, it's about the very fabric of our reality. And you could be part of the answer. The next discovery, the next breakthrough, it could start with the question that you ask. The universe is waiting. Uncover the universe's secrets with She Explores the Cosmos. Like and subscribe to join the journey.